welcome to another episode of I Am Nano.
Putting the I in I Am Nano, I am your host, Irfani.
And I am your other host, Monica.
And today, as part of our NanoLife series, we have a very, very special guest who will be sharing his experiences, advice, and opinions on pursuing a nanotechnology PhD and creating 2 nanotechnology startups.
Yeah, not one, but 2. That's amazing. Super excited to introduce Rob, who has graduated from a Nanotech PhD, as you mentioned, and during his postdoc in only 3 years has created these 2 nanotech companies. That is truly remarkable and excited to have you on the show.
Yeah, we're really, really excited to showcase you today, Rob. Let's start from the beginning. So what was your research focus for your doctorate?
So my main focus was exploring various nanomaterials for water purification applications to treat problems like pharmaceuticals in drinking water or algal toxins in blue-green algae. So I was trying to figure out and design different types of photocatalysts. So there are special materials that generate redox reactions when you apply either sunlight or UV light. So my main focus was on those materials and looking at the different applications we could use, like water filtration or to prevent corrosion in steel structures, and also to degrade like these emerging contaminants like different types of hormones, like endocrine disrupting chemicals that affect different types of fish and wastewater treatment effluents. So I looked at the whole gamut of water treatment applications.
So the goal is to basically make the water that we drink as clean as possible, right?
Correct. So there's different, it actually comes mainly from agriculture. So they pump a lot of hormones in the cattle or different types of animals, and they leach out these hormones like testosterone or estrogen. And they eventually end up in our wastewater system, but these wastewater systems don't fully degrade these compounds. And so it ends up in different types of watersheds, and these can affect the different fish that live there, especially the smaller fish like rainbow darters, which we have found in the Grand River. And they actually affect the male physiology and also their reproductive system. So they're not as active, and they're not
producing more babies.
They're not producing many babies, and so it kind of diminishes the rainbow darter communities.
It must have been very difficult to do all of that on top of, being a normal human being, I guess, in a way, and still, wanting to do all this work, but having, maybe normal social life or anything like that. We were wondering, what were some of the personal challenges you faced during your time as being a grad student, and I guess student overall, when, you saw maybe some of your other friends or peers that were not, they didn't keep doing school, they stopped at the master's or bachelor's level. They're out doing other stuff, having their careers, whereas you're still in school. Can you speak to kind of those personal challenges that you faced at all?
I think we can step back a bit. So when going into grad school, I actually calculated like the opportunity costs of going to grad school, at least financially. And I was willing to take that risk just so I could focus on research, which I really liked based on my co-op or cooperative education experience. So those are internships that occur in your undergrad, and Waterloo, which is the university I went to, was actually good with this program, and they offered you opportunities that most undergrad students around the world don't have the opportunity, which is to have some work experience. So I did that throughout my undergrad, and I really liked the opportunities where I did research. So that's why I chose to go to grad school. And in terms of my personal challenges, I think in 2015, I really hit a wall in terms of my research. And that was a point where I didn't want to step in the lab or do any work. And you could see it in my research record. 2015, I didn't do much work. And that was when I focused on other like personal goals. Like I haven't traveled much at that point. So I really got into the hobby of hiking. So I was hiking like different places in Ontario, different parks, camping out more often, which I've never done previously. So I really enjoyed that. And my goal at that time was to train to climb a mountain. It's called Mount Rainier, and that's located in Seattle, which is in Washington State, so West Coast United States. And I found that experience really enjoyable.
You climbed it. You actually climbed Mount
Yeah,
Rainier.
I climbed it, but with the help of like trained mountaineers.
Wow.
Yeah, so Mount Rainier is actually an active volcano.
Oh my goodness.
Okay.
You can actually smell the sulfur coming out of that volcano.
Oh my goodness.
Yeah, it was an interesting experience. It was challenging. I got high altitude sickness when I was up there, but I wouldn't trade that experience. I think it was what I was needed to finish my PhD. And in 2015, like I would take like 3 days off to spend time training for that climb.
Wow.
So I would train at Blue Mountain and Glen Eden. So they're ski hills in Ontario because we don't have any real mountains.
Yeah.
And some weekends I would go to New York State. So the highest peak there is Mount Marcy. So I actually trained at these mountains, and I had like a mountaineering bag with like rice bags in there to simulate like the weight I was going to carry in Mount Rainier.
Oh my goodness. Wow.
Oh my
Yeah, but yeah, that was probably not a good idea because some of those climbs I couldn't do with the rice bag.
Oh my goodness. How long did the Mount Rainier track take?
So that was actually a 3-day climb.
3 days?
Yeah, it was 3 days. You had to carry your own food.
Wow.
Yeah, we were with a guide and several other people who wanted to climb the mountain. You're kind of tethered to your guide and other people who paid to climb that mountain. And that's challenging, which we didn't account for. Like you're strapped together with another person, and sometimes...
Literally, you're strapped.
Yeah, you're strapped, and they're trying to... Sometimes they're lagging behind, so you could feel that tension. Like the physical tension, and they're kind of dragging you down, and everything feels heavier.
That's symbolic for like group work or something.
That's true. That's
yeah,
so true.
It's a good team exercise, I think. Something every research team should probably do.
I was wondering, do you think that it's common for PhD students to kind of like hit a wall at some point within their graduate career then, just drop everything and take some time off?
Yeah, I think it happens to everyone who does their PhD. You could probably say something to that, Monica or Fani, but I think most people do feel that maybe after their first or second year. I did go with a friend, and what he chose to do instead was to quit his PhD and just start working.
Really?
Okay.
So different people experience things differently.
Really?
Like
Okay.
when I finished the climb, I was more motivated to complete my PhD, whereas he found his calling. So he took a
Right.
year off, or maybe 6 months, and he started doing photography, which he really liked. And through that process, he started to think about the different types of jobs he wanted to be in, and he chose to be an optical engineer. So he liked optics, he liked photography, and I think that was a good fit for him. Whereas it motivated me, that experience, to, batten down and like do my research and
Get to
finish
work.
up my PhD.
Perfect.
And that also gave me the motivation to start a company with my supervisor and another friend who works at Myant. So that's a wearables company. Yeah, I think it was doing something different, something challenging that made me focus even more.
Well, I guess the question following up to that is, throughout the journey, would you say that there be anything you would like to do differently in graduate school?
For sure. I think going into grad school, I could have taken more internships in different types of companies during the early years, like the year 1 or year 2. Like perhaps looking at a different field, like say water treatment, I could have gone to a company like Trojan Technologies, which focuses on UV technologies, like do an internship there, or Veolia, all these different companies that probably have internship programs. I could have chosen to do that, and part of me also wanted to go to different countries and experience their university life and their cultures, especially in Europe, like Switzerland or Germany or Japan, and even Australia. And I didn't mention the States because I think it's more similar to Canada, and their culture is a lot of work. I think I don't think it's not a different culture enough for me to go to the States and do their research.
So essentially, just get as much experience and broaden your horizon as much as possible during grad school, right?
Correct.
Yeah.
Even if it takes a little longer, at least you're developing new skills along the way, would you say?
Yeah, developing new skills, learning another language and a different culture.
Yeah.
I think that would have been good, but I don't really regret the path I've chosen.
It's made you where you are today.
Yeah.
Really doing amazing things, you know?
Yeah. And I guess part of this equation is that you have to sacrifice some things for the goals you want to achieve. And my goal was to essentially take my ideas and prototype them and eventually commercialize them to the point where it becomes a business or company.
I guess actually I had a question on that too, or maybe you can both chime in here. I think a lot of the times people see, oh, you have a PhD, you're so successful, it must be easy for you. It's easy because you did it. It's easy because you're special. They don't really see like how hard you must have worked to get there. I don't know if you've ever experienced that kind of judgment or criticism your way at all.
I've never heard that criticism like explicitly. Maybe some people feel that way, and to them I would say like everyone has different skills and abilities, and the people who do PhD are typically people that like to try different ideas. They like to delve in different types of research and development. And they're also very open. They like to take in new cultures and experiences. And I don't think that's everyone. And it does take dedication and discipline to produce research papers. It's also, I find, lonely because you're trying different new things and not everyone's going to understand what you're trying to do, or I imagine your parents don't understand what you're doing, right? So describing it to them is often difficult. And yeah, I don't think anyone can judge like what you're doing. I think everyone has different abilities and skills, and they should try to develop them. And I think when you say that the people that criticize you, they're probably at a very young age, probably in their 20s, so they haven't had many life experiences. And I think as they grow, they'll realize everyone has a different journey, different life experiences and challenges. And I guess over time you develop a humility, and you don't have the same judgments of people. And that's what I find with at least my friends and the people that I know. Like maybe at a younger age they were more criticizing different people, but now they're more calmer, they're more humble, just because they've experienced different challenges in their lives.
Yeah, you're so wise. Thank you for sharing all that. So, Dr. Rob, what are you working on right now?
I'm working at a company called Nanotech as the head of product development. So over there, I'm responsible for the intellectual property development and managing the day-to-day activities for the research and development team. So at Nanotech, our technology is antimicrobial coatings and treatments for various types of nonwovens and textiles. We're aiming to apply this technology in several industrial fields, such as the medical field, the food and beverage field, transportation sector, and the HVAC and filtration sector as well.
Was the company started inspired by an event?
Yeah, so the company started at the height of the COVID-19 pandemic. So at that time, I was actually working on different types of mass prototypes as a volunteer. So we were looking at different PPE that could substitute for respirators and ASTM masks. So a lot of these respirators and masks were unavailable at the time. So we thought, well, what can we use to essentially get high filtration rate for off-the-shelf components? So we thought of using like resuscitation masks and inserting CPAP or resuscitation filters and incorporating them into a mass product, and just using like elastic bands as a strap for hospital workers who need the high filtration levels to operate in their job. So that was early in like April 2020, where
very early.
Yeah, where we didn't have the shipments of respirators or masks.
Right.
And so I volunteered my time for that project. I was also looking at like different disinfection technology to reuse N95 masks. And we did get a project out of that, like a small grant to study the effects of UV on N95. And around that time, I met my current CEO and head of industrial relations, Liang, and they contacted the Waterloo research office, and eventually my name popped up and we had a discussion, and they wanted to incorporate their antimicrobial technology that they initially had an idea for. and they thought I was a good candidate to help them deliver on that promise for at that time, their partner in manufacturing. So that's how I got to know them, and eventually, over the span of several months, we formed a company which is now known as Elision Tech.
So how did a PhD help you in that venture with Elision?
I think how my PhD helped me was essentially getting all that knowledge in material science and engineering. So I did say that I worked in different types of nanomaterials for water treatment applications, but the skills that you get from doing all those projects is that you can also apply the knowledge in material science and engineering into different types of applications, such as antimicrobial technology. So during my PhD, I not only focused on synthesizing materials for water treatment, but also in like 3D printing or thermoelectric materials. I've done antimicrobial coatings in the past as well. So that whole experience allowed me to better understand their problems and give a solution that was effective on a commercial scale.
In addition to the knowledge that you've gained both the hard and soft skills in grad school, I'm sure the challenges are a little bit different, right? This time with company, because in this case, you're not aiming to kind of produce a paper, but your aim is to make a commercial product, right? So what kind of challenges did you face when it comes to commercializing it?
The biggest issue is in the sales, right? So you have to, there's a lot, it's a more complex process. So you have to have the proper customer who will want this product and are willing to give you a good cut on it. So a good, you should make profit out of it. So you need to select a partner that is able to give you that. Second, you have to develop a low-cost product, preferably for this type of business. And with that, you're limited in the types of different materials you could use to incorporate like antimicrobial finish to a textile. So there's limitations there. Secondly, you have to look at the entire supply chain and quality management of the materials that you send to different vendors to get the textile treated. So they have to be available, they have to be available in bulk, and you have to, it's more people oriented, I guess I would say in general. And they have to eventually get paid, you have to get paid, and it's a difficult process. There's a lot of negotiation that's involved, and I think that's the most difficult process when you're comparing with academia. In academia, you're mostly focused on publishing. There's usually not many barriers that get in the way. It's just the struggles in R&D. But when you're dealing with a company, there's outside influences which you can't always control. And I think that's the most challenging aspect of like running a company.
So it's more people, more social challenges that's involved as opposed to technical limitations?
Yeah, it's almost like maybe like 1% technical.
Really?
The rest is managing people.
Really? Wow.
Leadership and negotiation and debate. So you're not always going to get your point across, or your point will not always be valued the same way as you might think it should be valued. And having, I guess, learning to deal with that and improving yourself. I think that's the most like rewarding thing, but also it's also ongoing struggle with entrepreneurs and myself included.
Would you say that for a scientific endeavor, novelty is highly valued in academia, whereas in a company, you're focusing more on developing the product? It doesn't have to be novel. So you're not trying to develop like this fancy new mechanisms or formulas to develop the product. You just need to get the product out and be able to package it to something that is in demand.
Yeah, so for academia, I agree with you that it's mostly on novelty, and you have to get papers that are novel in the sense that no one has done this before. It's a different approach to a scientific problem. Whereas when you're running a company, you're trying to solve a customer's problem to the best of your ability. Right. So you can solve a customer problems with different approaches, and the customer essentially has to like that solution to be able to pay for it. Right. And that's not always the most novel idea or mechanism that you might develop. It might be. So it's not always the case that the most novel solution is the best one. It's often the case the solution that solves most of the customer's problems or all of it, that's the solution you should aim for. And it might be the most simplest and the solution that is already available in the market. And it might just be a marketing play or how you package that solution to the customer that matters more.
Thank you so much, Rob. You're so wise. Thank you for letting us pick your brain for, this little while out of taking the time out of your busy schedule. So our last question is, where do you see the future of nanotechnology?
Ooh, that's a tough question. So I guess I can talk about what I'm trying to aim for personally, and I think you probably discussed it in your previous episodes. So I think graphene has like a lot of useful properties in terms of the mechanical, electrical, and optical properties. But the current problem is that it's costly right now, and with that cost, you can't really have it in different applications that you might want to integrate it with, like in different types of composite materials and using it for different filtration applications in my case. So I think the future of nanotechnology, or one of the futures, is the development of a scalable graphene synthesis technique that will allow graphene to be ubiquitous. So it'll be applied in your glass coatings, your water filters at a very cheap rate. And another path for nano is also in metamaterials and different functional materials. So with the advent of like AI and machine learning, I think materials discovery is going to be a much easier process than it is now. Right now, it's mostly like trial and error and a formal understanding of different chemistry processes. And I think in the future, when we integrate like AI with materials discovery, it'll be much easier to develop like novel materials, such as metamaterials, and having them integrated for various industries, like the automotive industry, for military and defense. The third avenue, I would say, as a possible future for nanotech. So right now, there's a lot of work being done in quantum computing. So companies like D-Wave, Intel, Google are all working on quantum computing. And I guess the biggest breakthrough they can achieve is try to achieve some sort of room temperature operation for these quantum computers. So right now they require low temperatures, liquid nitrogen temperatures, so close to 0 Kelvin to actually be useful in any computing operation. And it's also restricted to a small number of computations. So it's not really useful for a lot of our daily numerical computations that we might need for our applications. So like video streaming or if you're doing work on CAD, you wouldn't need a quantum computer for that. So scientists and engineers are looking at different applications for quantum computing and where it might be useful, maybe in cryptography. But to get to that level, I think we need some sort of room temperature operation.
Yeah, for sure. And just to define how cold 0 kelvins is, that's minus 270 degrees Celsius, which equals to minus 459 Fahrenheit. So if you think winters in Canada are cold,
it's even colder than that.
Even colder.
Yeah.
I think the coldest temperature in like Siberia is minus 50 Celsius. So much colder than that. So definitely I agree, we need room temperature operating computers.
Yeah, to get some supercomputers of the future, right? Yeah.
We do it.
Yeah. So there's a lot of cool things coming up in nanotechnology in the next few decades, and I think we're all very excited about them.
Thank you so much.
All right, thank you so much, Rob, again, for your time and for letting us ask you all these questions and for imparting your wisdom to everyone. So we will link all the work, well, not all the work, but his companies down below.
There's too many.
There's a lot of amazing things that he did, so we're gonna share it with you guys. You guys can also check it out. So that is all the nano for today. Take care
and stay curious.